Assalamu alaikum. Our today's topic is insulin chemistry and synthesis. Insulin is a small protein hormone and it has a molecular weight of about 5808. It is mainly composed of 51 amino acids and there is 2 amino acid chains in insulin, namely A chain and B chain. A chain containing 30 amino acid and B chain containing 21 amino acids, which are linked together by disulfide linkage. When the 2 amino acid chains are split apart, the functional activity of the insulin molecule is lost. When released into the blood, insulin circulates almost entirely in an unbound form. It has a plasma half-life that averages about 6 minutes. So, it is completely cleared off from the plasma within 10 to 15 minutes. For some portions of the insulin that bound to the receptors in the plasma, the remainder portion of the insulin is degraded by the enzyme insulinase. This degradation mainly occurs in the liver and to a lesser extent by the kidneys and muscles and other tissues of the body. This rapid removal from the plasma is important because at times it is important to turn off rapidly as to turn on the control functions of insulin. Now, the principal actions of insulin. The physiologic effects of insulin are conveniently divided into rapid, intermediate and delayed actions. The best known effect of insulin is hypoglycemic effect, but there are also amino acid and electrolyte transport, many enzymes and growth. There are these additional effects of insulin. The principal actions of insulin are rapid action, that means which occurs within seconds. Insulin increases the rapid entry of glucose, amino acid and potassium into insulin sensitive cells. Then intermediate action, that means those action which occurs from seconds to minutes. Insulin causes stimulation of protein synthesis and it causes inhibition of protein degradation. There is activation of glycogen synthase and glycolytic enzymes and inhibition of phosphorylase and gluconeogenic enzymes. Then delayed actions of insulin, that means those actions which occurs from minutes to hours. It increases messenger RNA and lipogenic enzymes. The net effect of insulin is it conserves carbohydrate, protein and fat into the body. So, we called insulin as hormone of abundance. The actions of insulin on adipose tissue, skeletal, cardiac and smooth muscle and the liver are as follows. On adipose tissue, insulin causes increased entry of glucose, amino acid and potassium. There is increased fatty acid and glycerol phosphate synthesis in adipose tissue and there is deposition of triglyceride. There is activation of lipoprotein lipase and inhibition of hormone sensitive lipase. On muscle, it causes glucose entry and there is potassium uptake and there is also amino acid uptake and ketone body uptake in the muscle. there is decreased protein catabolism and there is increased protein synthesis in the ribosome and glycogen synthesis. In the liver, it decreased ketogenesis and there is increased lipid and protein synthesis. Insulin act on the liver and there is decreased output of glucose into the blood by decreased gluconeogenesis and there is increased glycogen synthesis. In general, it causes increased cell growth and these are the overall actions of insulin. Thank you.